didn't understand one word he said. I'm Dutch, I don't speak Italian. Yeah, I'm sorry. Probably the only word I know is allora, which doesn't have any translation at all in Dutch. But you say it when you move on to something else. Allora. This is my heartbeat. This is my heartbeat. And it's a bit high. It's not because I'm nervous, but I'm actually terrified. Because this talk is about experimental technology and demos, hardware demos, and they can fail. And that's not a joke. Because last year I had a talk in London, the same talk, and the same demos, and none of them worked. I stood there in front of perhaps 300 people, and I didn't have anything to show them. Just the boring parts. Well, just to prove that this is my heartbeat, I'm now going to take off my heart rate monitor, my Bluetooth heart rate monitor, and then the patient has died. So, this was the first demo, and it worked. So I can relax. Switch over to my talk. Fun with Bluetooth. The first question I usually get when I do this talk is, why? Why do we need Bluetooth? Bluetooth in a browser isn't just regular things like JavaScript, style, CSS. Isn't that enough? Why must we do things outside of the browser? Why must we talk to devices using Bluetooth? And the answer to that is progressive web apps. And progressive web apps are great. They get you offline support, an app-like experience, add to home screen, and for many things, PWAs offer a better experience than native apps. But there is one thing that PWAs can't do. PWAs are bound to what the browser can do. They are great for talking to servers on the internet, but not so great for talking to devices you have at home. To do that, you need native apps. But I don't want to download a 500 megabyte app on my phone. Or the app is really crappy. Or it was built 5 years ago and it was never updated. I just want to use my laptop now and again instead of my phone, and they didn't build an app for my laptop. They only built a mobile app. And it's not just for constant use. It also offers a really good experience for setting up devices once. You don't need to install an app, you just go to a website and click some buttons and you're set up without installing anything. But why are PWAs or web apps not suitable for talking to devices? Well, my Sonos has Wi-Fi, and I have these fancy lights, and they also have Wi-Fi. And Philips Hue light bulbs, they have Zigbee, but they have a bridge, and the bridge is connected with Ethernet, so it has a network connection. And all of these devices run web servers. So you can just use fetch or XML HTTP request to talk to them. So what is the problem? Well, let's try. First, the first thing we have to do is find the IP address, because devices on a local network don't have domain names. So there, for you, for example, there is an API for that, provided by Philips. You call that, and it returns all the local IP addresses of all the bridges on your local network. That's because each bridge registers itself with Philips with its local IP address. And, well, if you use both the same external IP address, you're on the same network. So this works. Then you get a description.xml file from that web server. And you can get a version number, check if that's correct. Then you have to make an API call. And there's then a very important part. You have to physically press a button on that hub or bridge. Because, well, the API must know that you're actually allowed to do that. Otherwise, anybody could just turn on your lights. Like Sonos, for example, doesn't have any security at all. So anybody on your local network can just start playing music. And if I have the Wi-Fi password of my neighbor, for example, I can just go up in the middle of the night and play really, really annoying music. But Philips thought about this and he added security. That's good. Well, if you press the button, you get an answer back with a token. And if you have a token, you can make further API calls, like get the status of all the lights and set the status of the lights. So this is just a few fetch calls and just parsing some JSON. So we can build an app for this, a web app. Now let's say we do this and we try it out for the first time. And we click and we click and we click and we reload and we click again. And then we discover this does not work. Because PWAs can only talk to HTTPS. And the web server on the bridge only talks HTTP. That's because local devices on your local network can't get certificates. That's not possible. Because in order to verify a certificate, first you have to have a domain name, which you can't. And secondly, the registry has to verify that the server actually exists. And it can't do that because it's on the local network. So no certificates, no HTTPS. So network is good for using remote APIs, but really bad for accessing local devices. Now there's a workaround for this. Philips thought of a remote API, which means you talk to a server they control. And the bridge also talks to that server. And that basically means that when you turn on a light using your app, that signal goes to some server somewhere in China, and then goes back to your home, and then the lights turn on. Not ideal, but at least it works. But another problem, because this is what Philips says. We are currently preparing for release of this API, which will initially be available to a limited number of partners. And what they really mean is, it's 2 years ago, this, and it's still very limited because it's just Google Assistant and Nest and IFTTTTT, whatever. So this isn't useful to us. And if you thought I was kidding some server in China. Well, it may not be China, but I've got a picture here of their infrastructure. This is everything you need to turn on the lights. All right. So this has been PWA problems with local networks, and not fun with Bluetooth. So, fun with Bluetooth, finally. Well, when I say Bluetooth, I know when I start talking about Bluetooth, everybody says Bluetooth sucks. It's slow, it's limited range, pairing, it's 20-year-old technology based on, 20-year-old standard. But then you're thinking about classic Bluetooth. What I'm talking about is Bluetooth Low Energy, and that solves all of these problems and is actually a modern standard. It's known by many names, like Bluetooth Smart, Bluetooth LE, BLE, Bluetooth 4, and now Bluetooth 5. And if you're worried about range, with Bluetooth 5 the maximum range can actually get up to more than 1 kilometer between devices. That is not for in your home, but they managed to get it to work. And Bluetooth devices, there are so many of them. Every single day, 10 million Bluetooth devices ship and get into the hands of people. And that's phones, of course, and computers, but also serious medical applications like glucose monitors. They have Bluetooth. And for sport and health, activity trackers and heart rate monitors. And IoT, light bulbs, and just not serious applications, but fun gadgets supporting Bluetooth, like this cute robot, or drones, or fidget spinners. Yeah, let's get it. So first, before I get to the fun part, the boring theoretical stuff. And I'm sorry, I'm gonna have to explain some things, because this is not web technology. This may feel really weird. First of all, the naming. We have central devices and we have peripherals. A central device is a device that controls another device, like your mobile phone. If you have an app on your mobile phone, it controls a light bulb, it is the central device, and the light bulb is the peripheral. And if you have multiple peripherals, they can't talk to each other. They can only talk to the central device. It's in the middle. The central device could relay messages between the two, but you have to do that yourself. You have to program that. And we're not talking about Bluetooth Low Energy in general, but generic attribute profile. And it has a very obvious abbreviation. It's GAP, no, it's GATT, because GAP was already taken. And we're not talking about central devices anymore and peripherals, but clients and servers. So your light bulbs are servers. I have multiple servers in my house. My server has crashed, oh no. But when you think about it, it actually makes sense, because the light bulb offers a service. Light. So it is a server. And just like when you talk to a server on the internet, the browser is the client. In this case, your app or your phone is the client. Like I said, servers offer services. Well, in Bluetooth that means different types of information are exposed, like device information. That's a service. And light is also a service. And I don't mean physical light, but a way of controlling that light. That is the service light. And that isn't a standard because if you have 10 different light bulbs from 10 different vendors, that service is going to be different, unfortunately. Device information is a standard though. And if you have drone, you have battery and flight control. Flight control, again, is not a standard, but battery is. And this one also has device information and battery and steering control. And if you have a heart rate monitor, you expect battery, device information and heart rate, which is standard. But if you're cheap and you buy one of those cheap Chinese ones, it doesn't have device information, battery, and the heart rate service isn't a standard, so you have to figure that out yourself. But if you buy a more expensive one, you probably will get the standard. Now, if you look closer to device information, to a service, it has characteristics. Characteristics offer information belonging to device information, like manufacturer, model number, serial number, and so on. And you have multiple characteristics per service. And these are also standardized. Think of it like this. A server is like an array of objects. A service is an object. A characteristic is a property of that object. And they have a value. So this brings it a little bit closer to what we're used to, except they are really weird with their naming. But this is basically it. Except for that services and characteristics, they are identified by UUIDs and not names or keys. And they are 16-bit or 128 bits, and they look like this. The device information is 180A, and battery is 180F, and the small ones are reserved for standards, and the large ones anybody can use. But if you make your own service, you must stay out of this range because that's a standard. And of course, nobody listens to that. So even if you create your own service, you're going to use that 16-bit one, because why listen to standards? So if you look again at device information, it doesn't look like this when you look at a device. It looks like this. And that's very bad for readability. But it's very good for bandwidth. And with Bluetooth, you have limited bandwidth. So you have to know what these numbers mean. And for the standard, it's very well documented. If you have one of these characteristics, you can read from them, you can write to them, and you can get notified of changes. Kind of like add event listener. And every value is an array of bytes. Not fancy data types, just an array of bytes. So, phew. This was the boring theoretical stuff. How this looks. If you have an app that can inspect Bluetooth devices, it looks like this. I'm going to connect to a light bulb. And I have some services like device information and battery service. So I can look how far the battery is drained, 90%. And I have a couple of custom services because nobody has used a standard for lights. And I'm particularly interested to the top one here because it has 4 bytes. And if I change that 00000 to 00FF0000, then it turns red. If I change it to 0000FF00, it turns to green. And if I change it to 000000FF, it turns to blue. It's RGB. This is something we know. But what is that first one? if we change it to FF00000000, it turns white. That's because there are 4 LEDs in that light bulb. And each of these bytes control the intensity of one of those LEDs. So using this, we can change the color of that light bulb to any value we want, because we know hex colors. That's something we as web developers, app developers know. So, done with the boring facts. Let's have fun with Bluetooth. But first, the API. There is an API in the browser, the WebBluetooth API. It's experimental, it's new, and it is so much fun to play with. It isn't really that difficult, but you have to get around certain things, like the naming. So let's try it. Connecting to a device. You call navigator.bluetooth.requestDevice. And you provide a filter. You can filter based on name of a device, or you can filter based on services a device offers. And you have to specify each of the services you're going to use later in your project. And once you do that, once you call this, a dialog pops up, and your device will become visible. So the user actually has to select the device himself. Your web browser can't just connect itself to a device. The user has to initiate this. Once you do that, you get a promise back. And with that promise, you can connect to the GET server, and you get a promise back. With that promise, you can get a service, and with that call, you get a promise back. And with that promise, you can get a characteristic, and you get a promise back. So not that difficult, just repetitious. It's a little bit more typing to get to a property of an object. But it's basically the same thing. Now, once we have that characteristic, we can write data to it. We call write value with an array of bytes. And that's it. Data gets written to the device. Here I have RGB, and the first one I leave off. And if I provide a value for RGB, the light will turn on and become any color I want. I can read also the current color, reading data, and that works pretty similar. Again, I have the characteristic, and I call read value. And I get a promise back. And that promise contains the value of that characteristic. Now, you can also get notified of changes. So if you have a heart rate monitor, you don't want to read the value constantly. You want to not pull the information, but just get a notification when it changes. I also mentioned that kind of works like add event listener. That's because it is add event listener. You call add event listener on the characteristic with characteristic value changed, and you get the value back as a callback. But before you get values, you actually have to start notifications, because bandwidth is limited and you don't want to flood the network unnecessarily. And that's it. There are probably 5 more function calls, but I've never used them. You won't need them either. So things you need to know: is the WebBluetooth API. Well, you now know how that works. Promises and typed arrays. That's it. Browser support is kind of sketchy. You have Chrome, you have Opera, Samsung Internet, Servo, Safari. No, not Safari, of course not. That would be really strange. But on iOS there is a solution. It's called WebBLE. That kind of works. It's not a browser I would use for everyday browsing. But for demos it's absolutely fine. And it's not just a browser, because you have the same API in Electron. And you can install this API for Node or Cordova. So you can use the same API in all these platforms. And it's not just on your computer or phone, it's also hardware. I have this really small Bluetooth beacon, the Puck.js, and this one runs JavaScript. And the battery lasts around a year, and you can just use it for connecting to other Bluetooth devices. It has a button, it has an LED, and you can program it. You can program it to turn on a light, or whatever you want, because it's programmable by JavaScript. Now, I did encounter some weird things while playing with this. I mentioned that not everybody follows standards. But even not everybody is really, let's say some are weird. So the example I used so far, this is really sane. This is 4 bytes and we have 4 LEDs. I don't know a simpler way to do this. But if you have another light bulb, it might look like this. First, you have a really unconventional way of writing RGB, because it's GBR. I don't know why. And there are, for each color, there are 2 bytes. One to turn on the color, and one to turn it off, and one to change the intensity. But if you change the intensity to 0, you effectively turn it off. So why you have the switch, I don't know. And 2 of the 5 colors aren't used. But they are probably there because some light bulbs offer also warm white and cold white. So that's why there are probably 5. So this is okay-ish. This one is weird, because every byte has to be exactly like this. If you change one of these bytes, it will not work. I don't know why. You have RGB values, and if you look closely, there's a random number in there. That's because the message has to be different from the previous message. Otherwise, it will ignore it. And you have to make a CRC value. Well, this is weird. I also have these devices. LED matrix. Really cute to play with. This is really simple. You have a position and you have an RGB value. So if you want to change one of these colors, you send a position and you send an RGB value, and that's it. This one, well, this one, pretty similar. Well, you have to do a little bit more than that. A little bit more. Yeah. this is really weird because every message starts with a 1 and ends with a 0. So if you have a 1 or ends with a 2, starts with a 1, ends with a 2. So if you have a 1 or a 2 in the middle of the message, the device will crash. So what they did, well, you can have a color with a byte value of 2. So what they did is escape the 1s and the 2s in the middle of the message and escape them with a 3. So now I have to escape the 3 too, but that's just, I don't know why they did that. But this is stuff you have to deal with. How do you find out how this works? Because this isn't documented anywhere. So what you can do is sniff the Bluetooth network. With a small USB key, and you can just intercept the packets, because security. And, well, it isn't that bad, but okay, it is bad. But you can intercept the packets and you can, well, kind of figure out how it works if you use their app to see what happens on the network. And in the last case, if you still can't figure it out, there's another way. And don't tell anybody, but you can actually decompile APKs and look at the source code. That really helps. So, now it's time for the demos. Finally, the fun part. At least I hope. Because this is experimental technology. This may not work. In fact, probably one of these demos will not work. If one works, I'm happy. And it works at home. But at home, I don't have a room full of people with Wi-Fi devices. And Wi-Fi devices use the same frequency as Bluetooth. So this interferes with Bluetooth packets. So this may cause some issues. So during the demo, I'm going to ask you to tweet something. And please use this hashtag. I'll explain later. So, the demos. I'm going to prepare myself mentally. If I had the heart rate monitor still on me, I would just... Okay. Let's try this. I'm gonna plug in the power for a bit, just to be sure that my laptop doesn't die. Bigger. There it is. Well, we already did this demo, but I have plenty more. The light bulb. I'm going to turn it on. So let's see if I can change this color. Connect. And there it is. It already read the current color, so that's good. It worked. It worked. Different colors. it all works. I can even do this, or this, or use CSS Animations. So I'm running CSS Animations on a light bulb. I don't think you thought this was going to happen when you joined us here this morning. It isn't running on the light bulb, of course, it's running in the browser. And I'm just pulling the color of the light bulb in the browser to get the current color and send it over to the light bulb. But it's still cool. So, that was the first demo. I have a Lego car with me, and it usually has an RF receiver. But I changed that to a Bluetooth receiver. So if I turn this on, place it on the table, I can connect to it. And it works. Let's try this. Ooh. I have to be really careful not to drive off the table. So this uses the gamepad API. And well, the keystrokes are then sent to the device, and that's it. Or is it? What if we could use CSS Animations on that? Well, we can. There they are. Well, I'm not gonna do this because it turns circles, quite large circles, so it's gonna run off the table. What I could do is just remove some lines, left, right, just do the forwards, reverse. Let's do this, and then let's make that 70, 80, 90. What happens if we run this? There's a 2-second delay for me to get to the device. It works. The next one, I'm going to draw something on one of these pixel displays. And there they are. Let's pick this one. This takes a little bit longer than I'm comfortable with. Now I'm getting nervous. Now I'm checking. Like I said, probably one of these will fail. Let's try the other one. Yeah, that works. Well, let's try something. Yes. Let's do that. Oops. There it is. Now I'm going to leave these devices on, except for that one, because I don't want anybody to drive this off the stage. But if you want to change the color of this light bulb, you can if you go to bluetooth.rocks/lightbulb. And if you want to change one of these, you can go to bluetooth.rocks/matrix. You need an Android phone, a recent Android phone with Chrome. But then it should work. There is still one demo I want to show you. I'm going to disconnect so you can connect, because if one person is connected, the other persons can't anymore. So the first one to connect can control, and the rest, well, is out of luck. I'm going to try this. So I'll turn this on. This is a little receipt printer that they use in cafes or something like that. And I can connect to that. And if I have Wi-Fi, yes, if I have Wi-Fi, it will start printing every tweet with that hashtag. And that was the first one. So if you want to tweet something, use the hashtag UniversalJSDay. And it will print on that. I'm going to leave this open. So you probably noticed there is one more tab there. Oh. Oh. It works. I'm always so happy to see this. That last tab. Well, I mentioned drones. Did I? I have one here. But this ceiling is really low. I don't think I've ever tried it with a ceiling this low. And yeah, let's just. If I'm gonna crash, I'm gonna crash. So, I don't have much experience with this. And during the first test, I killed some plants. And there's a small Lego space minifig on top of it. And he almost got decapitated. So especially the people here on the front row, please watch out. It always takes a second to start up. Yeah, there it is. Bearing. So there's always one guy in the audience that looks at the screen and says, "Oh, drone, I'm going to try that." That's not funny. Now I'm connected, so you can't anymore. So let's see if this works. Not so high. So I can do a trick, but I'm really afraid it will crash. Okay. I'll buy a new one. Ooh, this is too high, too high, too high. Lower, lower, lower. Yes. This. Now you probably didn't notice, but I had to click several times on the buttons sometimes to get it to react because of the Wi-Fi interference. So this really was dangerous. But that was the last demo. It all worked. So, what we did was change the color of a light bulb. And all the demos are here on these URLs, and the code is available on GitHub on these URLs. I'll share these slides later tonight. So if you want to play with this, the code is there. Draw pixels on an LED matrix. Control a Lego racer using a gamepad. Control drone and print some receipts, tweets, okay, and find out your current heartbeat. So this was a lot of fun, but it's not just fun. These are real. There are actually real, important and serious implications to this technology, especially for the medical world. This can bring remote healthcare to a new scale. And think about collecting data from Bluetooth blood pressure monitors or glucose monitors, heart rate monitors. There are even Bluetooth EEG headsets that you can use with WebBluetooth. So you can build a demo that if you think about a certain thing, something will pop up on the screen. That is really cool. They're a little bit expensive. So, but getting all this data from the medical sensors and sending that data to your doctor in a safe and secure way, this is not just for playing in toys. So, that's it. Questions?